Hey guys, welcome to Buddi Academy. This is Vidya for you to teach Maths, and today's topic is Chapter 4 Determinants from your NCERT Class 12. And today we will learn only the important concepts in your determinant which will help you in the preparation of board exam. So pertaining to that, today we will learn the properties of determinants, matrix adjoint and matrix inverse, and the solution for the system of linear equation. So without further delay, we will move on to the class. First, in the properties of determinants, we will see the first property. See, the value of the determinant remain unchanged if its rows and columns are interchanged. See, in a determinant, if the rows and columns are interchanged, then the value of the determinant will not change. You know, value of the determinant is just a numerical value. So, the value will not change it. See here, for example, I have taken a determinant. Here, the row is changed as column. The rows are written as columns here, but then the values will be same. Okay, if you compute and find the determinant, its value will be same. Next, see second property. If any two rows of a determinant are interchanged, then the signs of the determinant changes. See, only the any two rows or columns. See here, for example, I have taken a determinant. Here, the row A1 is taken to the third row and the third row is taken to the first row. So, it is interchanged, right? If it is interchanged like this, then the sign of the determinant changes. Okay, that is both will have the same value, but the sign alone will change. Whereas, see here, rows are changed as columns and columns are changed as rows in the first property. Therefore, you will get the same value as the determinant value. But here, the row is changed its position. That is, first row is moved to the third row and third row values are moved to the first row. So, in that case, you will have the determinant value with its sign changed. Third property, you see, if any two rows or columns of a determinant are identical, all corresponding elements are same. That is, identical means all the corresponding elements are same. Then the value of the determinant is 0. See, if any two rows or any two columns, if all the corresponding elements are same, then if you take determinant value, then it will be 0. See here, first row and the third row both have same elements, right? Both have 3, 2, 3 and 3, 2, 3, both have same elements. So, if you find the determinant value, it will be same. Okay, see, I have given the computation for finding determinant also. You know finding, right? That is, for the first row and first column, that is 3 into, that is this element 3 into 3 2s are 6, 3 2s are 6. Then you have to change the sign, minus 2 into, it is, just strike out the first row and the second column, 2 into, see here I am finding the determinant with respect to the elements in the first row. Okay, you can even do it with the second row or third row or in the column wise also. Okay, minus 2 into, so I will take this 2. 2 3s are 6, 3 3s are 9, 6 minus 9 plus 3 into this 2 thing, 4. 2 2s are 4 minus 3 2s are 6. Now on computing, 6 minus 6 becomes 0. So 0 minus 2 into 6 minus 3 is minus 3 plus 3 into 4 minus 6 is minus 2. So, minus 2 minus 3 is plus 6, 3 minus 2 is minus 6, which is equal to 0. So, according to the property, if any two rows or any two columns are interchanged, then the value of its determinant will be 0. Next, see fourth property. If each element of a row or a column of a determinant is multiplied by a constant k, then its value get multiplied by k. See, in a determinant, if each row is multiplied by a constant value, okay, any constant. So, I have taken as k here. If each row is multiplied by a same constant value, then its value is equal to its values will be multiplied by the same constant. See, we have taken a determinant. Okay, so what I am doing, each value in the each element in a row are multiplied by a constant k. Okay, now for this determinant, you just find the determinant value. Okay, on finding the determinant value and on computation, you will get the value as a multiple of that constant. Okay, the same determinant with a multiple of the constant. Okay, hence you can also write like this. See, if any determinant is given like this with the same number as a multiple in any row, you can take that common multiple out and write like this. See here each row is multiplied by k. So in common I can take k out and write the remaining element. That's property 4 for you. Next, property 5. If all the elements of a row or column of a determinant are expressed as sum of 2 or more terms, then the determinant can be expressed as sum of 2 or more determinants. See here, suppose there is a determinant like this. Okay, see here in this row, or see, if some or all the elements of a row of a determinant are expressed as sum of 2 or more terms. See here, all the elements of this row are expressed as a sum of 2 terms. Okay, then the determinant can be expressed as sum of 2 or more determinants. So this one determinant I can express as a sum of 2 determinant. Okay, that is, see, just with the first value alone you can form determinant, that is a1, a2, a3 alone you can form determinant, and with lambda 1, lambda 2, lambda 3 you can form another determinant. If in case if you have plus if you have some other value, if you have psi 1 plus psi 2 plus psi 3, like that if the elements are sum of 3 values, then you can write one more determinant, that is you can express the determinant as determinant of sum of 3 determinants. Okay, like this you can express. See, all these why we are learning is to make your computation, to make the simplification in solving the problem very easier. You can just apply this property, or you can just write by property 5 and you can write the result to make your calculations easier. Yes, here we have a problem. See, in this determinant, in the second row, each term is each element is a sum of 2 values. So what I can do, with the first value I can write a determinant, and with the second value I can write another determinant. So this same determinant I expressed as sum of 2 determinants. Okay, now this is property 5, that's why it is written by property 5. Then see here, these 2 rows are identical. What is it? It is property, which property? If 2 rows are identical, you can write the value 0 by property 3. By property 3, if 2 rows or 2 columns are identical, then the determinant value is 0. That is what applied here. See here, 2 rows are same, then its property value is 0. That is, then the determinant value is 0 by property 3. And look at this value. Yes, see, here we are using property 4. It is a constant value, no? So this can be expressed as 2 into A, B, C, X, Y, Z and X, Y, Z. Okay, see again two rows are identical, so this value also will become 0. So that's why it is written 0 here, hence the value of this determinant is 0. So what property is used? Property 4. See, in the same sum, in the same example, we have used three properties. Okay, so this is how you will use the properties in solving the problems. Next one important application of determinant is finding the area of a triangle. See, in previous classes and all we would have learned a formula for finding the area of triangle when three vertices are given. Okay, and what is the formula? 1 by 2 x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now this expression can be written in the form of a determinant. So this formula, this expression for finding the area of triangle can be written in the form of determinant. That is, instead of this formula we can use this determinant formula also, that is determinant equal to, that is area of triangle equal to 1 by 2 x1 y1 and 1, that is x2 y2 and 1 x3 y3 and 1. Okay, so this is the formula for finding the area of the triangle. Okay, next we'll have some important points now. See, since the area is a positive quantity, we always take the absolute value of the determinant 1. See, here if you are finding the area of some triangle when the three vertices are given, okay, if you get some minus 54 as an answer, okay, you should take the positive value only. That is what given, because area is a positive quantity, so you should take only the positive value. Now if area is given, use both positive and negative value, and for some kind of application problem area will be given and any one vertices will be missing. Okay, any one vertex will be missing, that vertex you need to find. So in such problem, in such cases, you will use both the positive and negative values of the determinant for calculation. Okay, third one, see, the area of a triangle formed by three collinear points is 0. Okay, 3 points are given, no? For using this formula, this determinant formula for area of a triangle, 3 points will be given, right? So if the 3 points are collinear points, then the area will be 0. Collinear means what? Points on the straight line, points on a straight line. Okay, how can we form a triangle? How can these 3 points form a triangle? It is already a collinear, it is already lying on a same line. Okay, lying on a same line. So these 3 points cannot form a triangle, therefore the area is 0. Area of the triangle is 0. Okay. So these will be useful in, this will be asked in 1 mark, that is objectives also. Okay. Next, see, find the area of the triangle whose vertices are 3, 8, minus 4, 2 and 5, 10. We will solve an example for applying the area of triangle here. See, area of triangle is given by, what is the formula? Determinant equal to 1 by 2 into x1, x2, x3, y1, y2, y3, 1, 1. Okay, so we will just substitute the vertices here. This is x1, y1, x2, y2, x3, y3. x1, x2, x3 is 3 minus 4, 5. 3 minus 4, 5. y1, y2, y3 is 8, 2, 1. 8 to 1, and in the formula we have 1, 1, 1. Okay, and in the previous example we learned how to find the determinant, and you would have also practiced by now. So finding the determinant, 3 into 2 ones are 2 minus 1 into 1 1. So minus 8 into, that is you will neglect these two rows. Minus 4 into 1 is minus 4, minus 5 into 1 is minus 5, plus 1 into minus 4 into 1 is minus 4, minus 5 into is minus 10. Okay, so 1 by 2 into 3 into 2 minus 1 is 1. So 3 into 1 is 3, plus 4 minus 5 is minus 9, minus into minus plus 8 9s are 72, and minus 4 minus 10 is minus 14. So minus 14, which is equal to, on simplifying you will get 61 by 2 is the area of the triangle. Area, since it is area, you will write square units. Okay, so I hope you understood the problem. We will move on to the next concept. Next we learn the adjoint and the matrix inverse. For finding the inverse of a matrix, we should know the adjoint first of all. So first we learn the adjoint. So for learning the adjoint of a matrix and the inverse, definitely you should know the minus and cofactors. So we will see what is minus and cofactors. First is the definition for minus. So minor of an element, Aij of a determinant is the determinant obtained by deleting its ith row and jth column in which element Aij lies. The minor of an element Ai is denoted by Mij. That is, for the element Aij, if you are finding the minor, then it is denoted by Mij. Okay, so we have an important point here. See, the minor of an element of determinant of order n is the determinant of order n minus 1. That is, see, for a determinant of order n, if you find the minor, that minor will be the of order with 1 less than the determinant. That is, if you take a determinant of order 3, then if you find minor for any element in this determinant, that will be the determinant of order 2. Okay. Next we will see the definition for a cofactor. Cofactor of an element Aij is denoted by capital Aij and is defined by, see, minus 1 to the power I plus j Mij. Mij is what? The minor. Okay, minor of the element Aij. So for finding the adjoint, you should know the minor of an element and cofactor of an element. Cofactor of an element is what? Minus 1 to the power I plus j. I is the I and j denotes the portion of the element, and Mij into Mij, where Mij is the minor of Aij. See, we will see an example for minus and cofactors now. So see, first we will find the minor and the cofactor parallelly. See, for the first element, what is it? A1 2, sorry, 1 1. It is A1 1, that is first row, first column, right? So we have the minor. How to find the minor? By neglecting the first. For finding the element minor of the element in the first row, first column, you should neglect that first row and first column. If I neglect this first row and first column, what I will get? I will get this 2 cross 2 matrix, that is 2 cross 2 determinant. That is what written here. I will get this 4 0 0 4 5 7. I will get. Now multiply 0 into minus 7 is 0, minus 5 into 4 is minus 20. So minor of 2 is minus 20. Its cofactor also parallelly we will find. Cofactor is what? Minus 1 to the power 1 plus 1 into minus 20 is the minus. This is the formula. 1 plus 1 is I and j. Okay, minus 1 to the power I plus j, right? So, I is what? 1, j is 1 into the minus 20 equal to, so 1 plus 1 is what? 2, right? So, minus 1 to the power 2 is minus 20. Okay, then minor of minus 3, that is the second element. Okay, what is it? A, first row, second row. A1, 2 is minus 3. A, first row, third column is 5. Okay, like that for every element you have to find. So, A12 is minus 3. So, the minor of minus 3 is what? This first row, second column we should neglect. So, we will get 6, minus 7, 1 and 4. See, 6 into minus 7 is minus 42. Minus is there in the formula. Minus 4 into 1 is minus 4, which is equal to minus 46. You should be very careful in finding doing the determinant, because this minus is already there in the formula. Some people will forget to include this minus when some other negative number if you get as a product. Okay, you should be very careful in the usage of sign. So, you got minus 46. Now, here say the cofactor for this element. Okay, the cofactor for this element is minus 1 to the power 1 plus 2 into minus 46, which is 46. Okay, 1 plus 2 is first row, second column. This is first row, second column, right? So, and the element is also 1 and 2, A1, 2. So, 1 plus 2 is 3, minus to the power of any odd element is same minus, and you will have minus here. So, minus and minus into minus is plus 46. So, likewise you should find the minor of all the elements and the cofactor. Cofactor, see, there is a shortcut that using the formula. See, if you just add the I and j is what? It's a odd number, right? Odd number means you just write change the sign of the minor and write. If it is even number, see M11, 1 plus 1 is 2. 2 means you just, it's a even power. So, minus 1 will change as plus. Therefore, you should write the same as cofactor. If sum of this is same, sum of the element indicating row and column is same, that is first row, first column, it is what? Even. It is an even number. If it is even, you just write this same minor value as the cofactor value. If it is odd, you just write the same minor value with its sign change. If it is minus, you can write plus. If it is plus, you can write minus. See, 1 plus 3 is 4. Okay, even. So, don't change the sign. Directly you can write. 2 plus 2 is even again. Don't change the sign, directly write as cofactor. Here, 2 plus 3 is 5, change the sign. 3 plus 1 is 4, here minus 12, 4 just don't change and write as it is. 3 plus 2, 5, so change the sign. 3 plus 3 is 6, don't change the sign. So, if it is even power, don't change the sign. If it is odd power, change the sign for the cofactor. Okay, I hope you understand. Hence, we have got the minus and the cofactor for all the elements. Next, we will see the adjoint of a matrix. We will first see the definition for the adjoint. The adjoint of a square matrix A equal to Aij n cross n is defined as the transpose of the matrix Aij n cross n. That is, see, what is it? cofactor, right? After finding the cofactor of all the elements, I put it in a matrix. Okay, put it in a form of matrix, and by taking its transpose, we will get the adjoint of that matrix. Okay, we will get the adjoint of that matrix. See, in the previous sum we just got all the cofactors, no? All these cofactors you put it in the form of matrix and find its transpose, you will get its adjacent, you will get the adjoint of the matrix. Transpose means, you know, in the matrix class we have done transpose of a matrix is writing the rows as column and columns as rows. Okay, see here, for this matrix, for each and every element find the cofactor. Cofactor of A11 is capital A11. Cofactor of A12, the element A12 is capital A12. So, finding all the cofactors and putting it in the form of a matrix, and you will get the adjoint of A by taking the transpose of this matrix. Transpose means writing the rows as column and columns as row. First row as first column. See, A11, A11, A12, A13. Okay, then second row as second column. A21, A22, A23. Third row as third column. And that's how it goes. That's the important remark. For a square matrix of order 2 given by A equal to A11, A12, A21, A22, adjoint can also be obtained by interchanging the A11 and A22 and by changing the signs of A12 and A21. See, if there is a matrix, square matrix of order 2, and if you want to find the adjoint, okay, for this you need not go for the cofactor method. Okay, you just interchange the element and change the sign of this element. Okay, that is A22 will go as a first element, A22, and A11 will come here, and these two elements will remain in their places, but their sign will change. Okay, that is what given here. See, these two elements will interchange their positions and these two elements will change their sign. This is only for your square matrix of order 2 for finding the adjoint of A. Okay, in adjoint we have an important theorem. If A be any given square matrix of order n, then A into adjoint of A equal to adjoint of A into A, which is equal to determinant of A into I. Okay, see where I is the identity matrix of order n. So, this you may get as a problem in your exam also. They will give some matrix and they ask you to prove this. Okay, that is the product of A and the adjoint and its adjoint, and adjoint and its A both will be same, which will be equal to the modulus or determinant A into the I. I is the identity matrix. Identity matrix, you know, right? In the previous chapter we saw what is identity matrix. If not, you can refer to the previous video, that is chapter 3, matrices. Next, definition 4. See, a square matrix A is said to be singular if determinant of A is equal to 0. For finding the inverse of a matrix, you need to know whether the matrix is singular or not. Okay, that's why we are learning this definition. Okay, matrix A is said to be singular if its determinant value is 0. For example, see, determinant of matrix A equal to this matrix is given, it is 0. Okay, therefore it is a singular. It is 0, right? See, 8 ones are 8 minus 4 twos are 8. This is 0. Determinant of this matrix is 0. Therefore, this matrix is a singular matrix. Okay. See, another definition, a square matrix A is said to be non-singular if its determinant is not equal to 0. if a matrix is given and if its determinant value is 0, then it is a singular matrix. If its determinant value is not 0, it is a non-singular matrix. There is a theorem in the concept of singular or non-singular matrix. Why we are learning all this? For finding the matrix inverse and for solving any equation, you need to know whether the given matrix is singular or non-singular matrix. See, if A and B are non-singular matrices of same order, okay, both are non-singular matrices. That is, if you take determinant of A and determinant of B, both should not be equal to 0, but they should be of same order. Then A into B and B into A are also non-singular matrices of the same order. Then if you find the product of both the matrices, that is A into B and B into A, they will be also a non-singular matrix. Okay. Then theorem 3, you see, the determinant of the product of matrices is equal to the product of the respective determinants, and that is, see, suppose you are taking two matrices and finding the determinant. Okay, for the matrix A and B, if you find the product, and for that product if you take the determinant, that will be equal to the product of the determinants which was found separately. Okay, where A and B are square matrices of the same order, where A and B should be the square matrices of same order. Okay, then in general, if A is a square matrix of order n, then this result U is also very important. Adjoint of A, okay, that is determinant of adjoint of A equal to what? Determinant of A to the power n minus 1. Okay, it is mod A to the power n minus 1. Next we will see a theorem on a singular matrix. See, a non-singular matrix. See, a square matrix A is invertible only if and only if A is a non-singular matrix. That is, if you want to find the inverse of any matrix, first you should check whether it is a singular or non-singular matrix. If it is non-singular matrix only, you can be able to find its inverse. Okay. So, we will now see an example for finding inverse and for verifying this theorem also. Okay, for verifying this result in the theorem which we learned previously. Okay, see the example, they have given a matrix A, okay, and we have to verify this and also have to find the A inverse. As I told you before, for finding A inverse, definitely you should check whether it's a singular matrix or non-singular matrix. How will you find it singular or non-singular? You will first find the determinant of that value, determinant value of that matrix, and if the value is a non-zero, then it's a non-singular matrix. Okay, see, for the given matrix A, we have found the determinant which is 1 and it is not equal to 0, and hence it is a non-singular matrix. So, exist, A inverse exist. Okay, now first we will do this part, adjoint of A. For finding the adjoint, we need to find the cofactor. Okay, you know how to find the cofactor, already we have seen a example on that. So, likewise you should find the cofactor of all the elements. Okay, and writing all the elements and taking its transpose will give you the adjoint of A. Okay, will give you the adjoint, that is, see, the cofactor matrix of the cofactor is 7 minus 1 minus 1 and minus 3 1 0 and minus 3 0 1. Okay, if you take the transpose of this matrix, transpose means writing the rows as column and columns as row. Okay, if you take transpose of this matrix, you will get the adjoint, you will get the adjoint of A. Next, we have to find A into adjoint of A. So, multiply the matrix A with the matrix adjoint of A. Okay, multiplication of matrix already we have learnt in the chapter matrix. I have given you a shortcut method which in which you will make less computation error, provided you should do it carefully. Okay, it is very easy comparing to the classical way of finding the multiplication of matrix. Okay, you can refer to the previous video, practice on that and do. Okay, so on multiplying these two matrices, I got a identity matrix. I got a matrix which is the identity matrix. So now, which is equal to determinant of A into I, that is 1 into, I got a identity matrix, no. So with that I am just multiplying 1 into the identity matrix, 1 value of the determinant of the matrix is also 1. So in place of 1 I am just substituting the determinant of A into I is the identity matrix. Okay, hence we verified, that is A into adjoint of A equal to determinant of A into I. That is what is asked to verify here. It is verified. Next we will see how to find A inverse. Okay, as we got the matrix, the determinant of the matrix is a non-singular matrix. By finding its determinant, we have a formula to find the inverse of A. That is 1 by determinant of A into adjoint of A. We have already found the adjoint of A and determinant of A also we got. We now have to just substitute the value. So 1 by determinant of A is 1 into adjoint of A. Adjoint of A just now we got. So this is the adjoint of A. We will just directly substitute here. Okay. Since it's 1 by 1, we have the same matrix. If it is something else, if it is like 1 by 2, what you will do? If it is 1 by 2, you will just divide all the elements by 2, but it's just 1, so I got the same matrix. So this is how you should find the inverse of any matrix. So before finding the inverse, you should check whether it is a singular matrix or non-singular matrix. You will get the inverse only if the given matrix is a non-singular matrix. So of course you need to find the adjoint. By finding adjoint of the given matrix is a long process, right? So before that, if you got the given matrix as a singular matrix, you need not to find the adjoint also, because A inverse does not exist in that case. So first find whether it's a singular matrix or non-singular matrix, then go for your adjoint, go for finding the adjoint of the matrix, and then you can substitute in the formula and you can simplify to get the A inverse. Okay, in case if suppose any other number we got here, you should multiply inside the matrix with each and every element of the matrix, or if you get any other number in the denominator, you should divide every element with the same number. Okay, but here we have 1 by 1, hence on multiplying with 1 I got the same matrix. Okay, so I hope you understood this, and practice more. Okay, only on practice you will take less time to solve these problems. All these problems are time consuming problems, but only if you practice you will get the correct answer with less time and with no error, with no computation errors. Next we will see the solution of system of linear equation. This is another application of determinants. Usually solution of linear equation we will solve in algebra by using the elimination method and substitution method, but here we can solve the system of linear equation by using the determinant method also. We will see that method now. So before going for the solution of linear equation, first know what is consistent system and inconsistent system of equation. Okay, consistent system is a system of equation is said to be consistent if its solution, that is one or more solution exists. That is, if one or more solution exists only, it is a consistent system. Okay, a system of equation is said to be inconsistent if its solution does not exist. If a set of equation is given and there is no solution exists, means then it is said to be inconsistent system of equation. Okay, next we will go for solving an equation. See, solution of system of linear equation using inverse of a matrix. Okay, here you will use the concept of inverse of a matrix for finding the solution. Okay, see how to find. Consider the system of equation. This 3 equation let us consider. Okay, for leave the variables and take the coefficients alone. Take the coefficients in all the 3 and arrange it in a matrix and let it be matrix A. Okay, and let it be matrix A, and let capital X be a matrix, or let it be a column matrix of element x comma y comma z, x y z. Okay, if it is some other elements, some other variables like p q, or also you can do it here. Okay, if it is if the equation is of the variable p q r, you will write p q r here. Okay, and B is just going to be the column matrix which possesses the elements which are the right hand side of the given equation. Okay, so all the coefficient you will take and write it as a matrix A, and all the variables you will write it as a column matrix which is X, and on the right hand side constant value you will take and you will write it as a column matrix B. Okay, suppose if the right hand side is 0, that is, see, 3x plus 4y plus 7 equal to 0. In this case, what you will do, see, x coefficient of x is 3 and coefficient of y is 4. There is no z term. So, for z, here in place of z you will have 0 z, that is 3x plus 4y plus 0z equal to, take this to the other side, equal to 7, and this will go to the matrix B. Okay. Now, so this system of equation can be written as, now the equation we just written in the form of matrix, the given equation we have written in the form of matrix. Then this matrices itself we can write as a equation, that is A into x equal to B. A into x equal to B we can write. Okay, like this you can write, that is the matrix A into the matrix X equal to the matrix B. Okay. Now, if there are 2 cases in solving this, if A is a non-singular matrix, why we are finding matrix if a matrix is singular or not? Because we are using by matrix, we are solving by matrix inverse method. Okay, if A is a non-singular matrix, then its inverse exists. Okay, so first of all you should check whether the matrix is a singular or non-singular matrix. If it is non-singular matrix, then its inverse will definitely exist, no? So what you will do, the given equation we have written in the form of matrix, and the matrix you have just written like this, no? Since it's a non-singular matrix, the inverse exists. So what I will do, I want the value of this matrix alone, because the matrix X contains the unknown variables x, y, z. Okay, if I got a equal matrix for this using the equality of matrices, I can equate each and every element and find the value of the unknown variables. So to eliminate this A from the left hand side, to remove this A from the left hand side, I am just multiplying both the left hand side and the right hand side with A inverse, because A inverse exists. Yeah, right. So A inverse exists. So A into A inverse is what? I, the identity matrix, equal to A inverse B. Therefore, X equal to A inverse B. So from here you can directly even write this. Okay, x equal to A inverse B. Okay, this matrix equation provides unique solution for the given system of equation as inverse of a matrix is unique. This method of solving system of equation is known as matrix method. This method is also known as matrix method of solving the system of equation. This is case 1. Next we will see case 1. Case 2, if the given matrix is a singular matrix, that is its determinant value is 0, what you will do? In this case, we calculate adjoint of A into B. Okay, if adjoint of A, that is, first you should find the adjoint of A and multiply with the B, the matrix B. Adjoint of A into B is equal to 0, is not equal to 0, then the solution does not exist and the system of equation is called inconsistent. Okay, if the value of adjoint of A into B is not equal to 0, it is inconsistent. If it is equal to 0, then the system may be either consistent or inconsistent according as the system have either infinitely many solutions or no solutions. So, if it is equal to 0, then the system may have infinitely many solution or no solution. Both the possibilities are there. See, if it is not equal to 0 means it is inconsistent. You can write it is inconsistent, hence there is no solution. Okay. 0 means what? It's a 0 matrix, not a value constant 0. Okay. 0 is a 0 matrix. Okay. That is 0 matrix is what? Every element in the matrix is 0. Okay. So, in that case the solution does not exist and you can write the system is inconsistent. Now, if suppose it is equal to the 0 matrix, that is a singular matrix, then you can write the system may have infinitely many solution or no solution. Okay. So, both these cases may occur while solving the solution, okay, while solving the problem and while finding the solution. Now we will see an example for finding the solution by matrix method. As I told you, by using matrix inverse, the method is also called as matrix method. Okay, see, first check whether all the elements, all the variables have value in every equation. XYZ, XYZ, XYZ is there, and check whether the arrangement is correct. Okay, here is where many people will do the careless mistake, silly careless mistake. Sometimes these terms x value, y value, z value may be interchanged. The value may be interchanged, like z will be given first, y will be given third, and x will be given second, like that. So in that case, what some people will do, they will simply copy the coefficient values and will do the sum. At the end your solution will be wrong. So first check for the question, check whether the question is there in the correct order. Okay, or else you can change the order. Okay, here everything is correct, then we can go for solving the question, solving the equation. See, the system of equation can be written in the form of Ax equal to B. Okay, like this. Next, we should we should find the, what is the A inverse? 1 by determinant of A into adjoint of A. Okay, but we are not using it now. First determinant of A we will find. Okay, why we are doing this is, inverse we need to multiply the inverse with B. So first find the determinant of A. Determinant of A is not equal to 0. Therefore, it is a non-singular matrix. Therefore, the inverse exists. That's what given here. A is a non-singular matrix and so in the inverse exists. Now, how to find the inverse? It is 1 by determinant of A into adjoint of A. For finding the adjoint of A, you should find all the cofactors. And write its transpose. So, see, these all will be the elements in the first column, but that will be written as first row. Second column will be written as second row. Third column will be written as third row. That is the transpose. Taking transpose for finding the adjoint. Now substitute in the formula. This formula I told you, A inverse formula. So 1 by determinant of A into adjoint of A, and we got the A inverse now. Okay, and how to solve the equation? X equal to, that is Ax equal to B we got, no? So as we see in the definition, since it is the matrix is invertible, x equal to A inverse B we can write, x equal to A inverse B. So A inverse is this full B is A inverse into B. This is the matrix B. Okay, now you have to multiply. You have to multiply these two matrices. Okay, I taught you a easy way to multiply, right, in the previous class. Please refer to the previous video. So multiply so that you will get a matrix like this. You will get a column matrix. Okay, why we are getting a column matrix? This is a matrix of 3 cross 3 and this is a matrix of 3 cross 1. Since the number of column and the number of rows are same, you can multiply, but then as a result you will have a matrix. The end product will be the matrix of 3 rows 1 column. That is a column matrix you will get. That is what we have done here. So we got a column matrix on multiplying these two matrices, and we have 1 divided by 17. So again you multiply inside. It is you multiply this 1 by 17 with each and every element in this matrix. So on multiplying with 1 by 17, so 17 gets cancelled, so 1, and on simplifying 34 2 times is 17, 51 3 times is 17. Okay. So what is this X matrix? X is the column matrix of all the variables. Okay. Now by equality of matrix, you can equate the elements. First element in the first row will be equal to 1, and element in the second row, element in the third row. Therefore x equal to 1, y equal to 2 and z equal to 3. Therefore we got the value of unknown variables here. Okay, I hope you understood. We will go for a short recap for this problem. It's a very important question. This type of problem definitely students you need to practice. Okay, again and again you need to practice so that you will do these calculations very fast and without any error you can perform it. See, system of equation is given, and first you check whether all the variables are arranged in order. Sometimes it will be given like this, 3z plus 2x minus y, like that. So in that case what you should do? 2x minus y plus 3z. First you arrange it like this, and then you can take the coefficient and form the matrix A. Okay, matrix X is nothing but the column matrix of just the variables given in the equation. It can be x, y, z. What variable is given in the equation, that variable you should write. It need not be x, y, z always. If the equation is given as PQR, you can write PQR. Then B is the right hand side column matrix of values which is given the right hand, that is the constant values. Okay, for finding the equation by matrix method, we need the A inverse of the given matrix A. For finding inverse of the matrix, we need to check whether it's singular or non-singular matrix. So for finding the A inverse also, we need the determinant of A. So find the determinant of A and see it is not equal to 0, hence it is a non-singular matrix, and therefore the A inverse also exists. Okay, therefore we will find the A inverse. The formula is 1 by determinant of A into adjoint of A. So we need to find the adjoint. For finding the adjoint, you should find all the cofactors of each and every element in the matrix, and the cofactors, the matrix of cofactors, if you take the transpose, you will get the matrix adjoint of the matrix A. Okay, and on substituting it you got A inverse, and the same A inverse. See here, never multiply this term in front of the matrix here itself. Okay, then if you do that, your multiplication here will be very tough. Okay, try to keep it in the simple form, don't simplify here itself. Okay, this just as it is you substitute in the equation, and on multiplying you will get a singular matrix, not singular matrix, a column matrix. You will get a column matrix by equality of matrix, okay, which we learnt in the previous chapter. Okay, equality of matrix, you can equate the elements, that is x equal to 1, y equal to 2 and z equal to 3. So hence we got the solution for this set of equation, for this system of equation. So guys, in this chapter you have to just get thorough with all the statements of important theorems. Okay, the statement of theorems and the equation in the theorem, that is result in the theorems, may be asked in your exam to verify or to prove. So it is better to memorize or to get thorough with that statements and the results. Okay, again, important results, important properties, you have to get thorough and practice all the application problems like finding the area of triangle, solving the system of linear equations. All this you have to get thorough and try to solve the previous year question paper. Okay, previous year question paper, if you have, you can solve it. Okay, practice as much as possible. Okay, you fix a time and try to finish the practicing on the fixed time so that you will not waste time in your exam. So practice as much as possible to reduce your time in the exam. And most important, if you have not gone through the matrix, gone through the lesson matrix, this this topic will be very much difficult for you, because everything, all the basics you will learn in the matrix, like singular matrix and finding the rows and columns, multiplication of matrix, all that you would have learned in the matrix. But if you skip that chapter, this topic will be very much difficult for you. Okay, so first get thorough with the matrix lesson and then come for the determinant. If you have not yet learned a matrix, you can refer to the Buddy Academy video for the previous chapter matrices, and then you can come back to this chapter and learn it. So guys, in this class we learned the properties of matrices, matrix adjoint, matrix inverse and the solution for the system of linear equation. So get thorough with this concept and be very careful in doing the calculation and the usage of sign. I hope the class is very useful for you and you enjoyed the class, and in the next class I will meet you with another new chapter, that is chapter 5, continuity and differentiability. Thank you.
For more queries, please contact Buddy on 98408 44987 or visit buddi.live.